I'm Rosalind Dalberg. Welcome to our physics class. Today we're learning about projectiles. So guys, we've been learning about projectiles. Today we're going to keep going and we're going to do some more to demonstrate the independence of the perpendicular components of projectile motion. Now, tell me what those two components are.
Vertical and horizontal.
Okay, so the key to this is to separate the vertical and the horizontal motion. And so we'll kind of review that. Now, this whole unit, kind of marries everything we've been doing. We've been studying constant velocity, we've been studying accelerated motion, and now these are complicated problems. We're putting all of that together. And so all these things that you've been doing, you've been learning about solving these problems both with math and graphically. You've been learning what those displacement time graphs mean. If you look at a graph, can you identify what kind of motion? The velocity time graph as well. And you've been figuring out how to solve for different variables if you're given a few pieces of information in actual situations, and today we're going to do that again. So when we started, you came in, this was your bell ringer. If you have a cannon, and one cannon is shot horizontally at 175 miles per hour, the other one is dropped at the same time the other one is fired, which one hits the ground first? Tell your neighbor, tell your shoulder partner. Okay. Would someone like to share? Yes. You think they hit at the same time? Okay. Yes.
I think that since one's going at 175 miles an hour, probably hit first.
So since it's going faster, it's going to hit first? Okay. Why would you say it hits at the same time? Do you have a reason or just? Because they're going the same speed? Okay. Okay. Anybody else want to share? Victor?
I was just going to add on to our answer saying that they're fired and dropped at the same height, so gravity works on them equally.
Okay, they're fired and dropped at the same height. Okay, so gravity's going to work equally. But does the fact that the other one is going faster matter?
Yes.
Okay, I should have brought my cannon to school, huh? I did, y'all. Okay, so. Okay, my cannon looks different than an ordinary cannon. So here's my cannon. I'm going to move this table out. Okay, guys. So here's my cannon. I'm going to pull this back, and one of these balls is going to be fired, and one of these is going to be dropped. Now, how are we going to know if this one hits first? So this one is the one that's going 175 miles per hour. How are we going to know if this one hits first? Okay, you'll hear. And if they hit at the same time, we'll hear. Okay. Okay, y'all ready? Ready, aim, fire. Ooh, what did y'all hear? Same time. Okay. Can you tell me why? Why at the same time? Yes.
The horizontal and vertical components are independent of each other.
Okay. So that horizontal motion doesn't matter. The vertical falling motion's independent? Okay. Okay, guys. So next what I want to do with you, do you remember before we started this unit we watched that video of Kobe Bryant? Okay. And this is a YouTube video of Kobe Bryant jumping over a pool. I'm gonna hit the light so we can see it a little bit better. Today we're gonna analyze that video. So is it real or fake?
Fake.
That's real.
Nah, man, I believe in Kobe.
Real or fake? Okay. Right now, no one knows. Okay. Go ahead and hit the lights again. Right now, no one knows, including me. So if I give y'all a problem, I know the answer. And so I just kind of wait for you to figure it out. This one, I don't know. If you want to know the answer, you have to figure it out. So when we started this unit, you analyze a basketball shot. You're going to take those skills and you're going to use it for that video. And after, you're going to present in a board meeting. So what do you need? Okay, what else? A board, a calculator,
And a laptop.
a laptop, okay.
Oh.
So the video, so figure out what you need. The laptops are over here. Go ahead and work in a small group. You can decide. Do y'all wanna do groups of two?
We have an auto.
Okay. You're good. So go ahead, decide how big your group is. If you have a group larger than two, use more than one laptop. Okay. Which one are you doing? The XY axis? So up here, if you just change that to maybe 10, and at the bottom one, maybe 0. Right here, change that, okay. Change that one to 0. -10. But change this. Okay, here's your 0 line. I don't see your points. Okay. So if you look at this, did y'all set the scale for your video?
Because the video changes. I can do it right there. What's up?
Happy birthday, Jacob.
Didn't even see it on the roll.
I didn't. Happy birthday, Jacob. How are y'all doing? Ooh, very nice. Is that the only evidence though? Can you find more evidence to support your claim that it's real? Ooh, nice. Can you put all that on the board for your discussion? So, this is evidence. Can you offer more proof for your claim? Okay.
Not even close. How do you make it come back to front of the graph?
How do you want the actual video?
Yes, ma'am.
Okay, it's right there.
Oh, you see, like 3 different.
And that's a graph right there.
And what graph is it?
If you click on this one, it will bring it to the front. And then you can, if you click on the axes, you can change them. That's a very pretty graph.
This one? What, this one?
Everybody analyze the same video. How many of you claim that it's real? Raise your hand. Okay. I have a few groups, 3 groups, 4 groups saying it's real. How many groups are saying it's fake? Okay. So I'm going to let y'all figure this out. So I want you guys to take turns discussing your results and your evidence. So which group would like to start?
Okay, well,
Jack and Caitlin?
we said that the video was real because the horizontal velocity was constant with a negligible slope of 0.0 something. And the vertical velocity was at -10 meters per second, which is almost consistent with gravity.
We had about the same thing, our reasoning. The slope was 0.09, which is pretty much 0, which is the constant for horizontal motion. And our vertical slope was negative 9.178, which is close enough to 9.8 or negative 9.8. So that's why we're saying it's real, because those two things tie in with a real
Okay.
projectile.
So you think the acceleration is close enough to, the acceleration that we know?
It's close enough to say that our human error could have skewed it enough.
Yes. Was it hard to place the dots on him at the same point?
Yes.
So could there be some error introduced?
Yes.
A little. Okay. Anybody else that said it was real? Let's see what you have.
We said that our horizontal was 0.172 meters per second squared, and that our vertical was negative 0.162, which is, they're both within reasonable error.
Okay.
Well, our horizontal velocity was negative 1.3, so we kind of just figured it out as error, so rounded up to 0, and then our vertical acceleration was negative 8.8, so we figured that was close enough to negative 9.8, that we just messed something up.
Okay. So yours wasn't it was close enough that you couldn't say that it wasn't due to
Yes,
gravity? Okay. Now, the contenders who say that the video is fake. Let's
I
see.
mean, first I want to say that I'm a little bit upset that Kobe would lie to us. And then, second, we were pretty spot on. I'm not saying we're perfect, but our calculation was right. And the horizontal acceleration being 0.35 and the vertical, which isn't 0 like it should be for acceleration. And then the acceleration negative 9.2 is not correct. We're negative 9.8.
Okay.
That is considerable distance.
Is it? So is that far enough away that we could consider it fake?
Yes.
I don't know.
No.
I don't know.
Our vertical
Gravity was changed.
Yeah, our vertical was like a whole meter,
You can see it from a piece of
which is enough to counter.
Okay.
It's okay.
Justin, how about your group?
Adam, do you want to explain?
Yeah, sure. Well, I'm gonna go ahead and agree with Jacob that the like 0.8 difference in the y velocity isn't enough, even with human error, to say that it is gravity. So we got like 9.1 as well for the acceleration.
Okay, you have an acceleration of negative 9.1?
Yeah.
Okay. Okay, any other evidence? So you have a few other things on your board.
Well, the horizontal velocity also wasn't close enough to 0 for us. It was more around 0.6.
Okay. Victor,
Yeah.
how about your results? What did y'all have?
That's what we had, and like the vertical velocity was like a whole meter long.
Was a whole meter off? Okay. Okay. So y'all had similar results?
We did. Ours is a bit more drastic because ours are right.
Okay. So I'm gonna step back. I'm gonna give y'all a few minutes as a class, discuss, and tell me. As a class, you have to come to a conclusion. Is it real or fake? So you've looked at everybody's results, real or fake, so talk. Can we make a claim whether it's real or fake?
Fake.
It's real. It's fake.
Yeah, so not necessarily.
I can't.
The ones who claim that it's real are pretty close
Yeah, I'm pretty close.
to the acceleration due to gravity. And the ones who claim it's fake, aren't far enough away.
Yeah, it's called human error.
So I think this would involve more investigation maybe. Okay. So if you take this tool and take it home, analyze a video of someone jumping off a building, is it real or fake?
While they're real.
What would you look for? So how would you explain to someone else how to do this? Yes.
Don't look for your y and x motion. Your x should stay as close to 0 as it can for the acceleration, and your y should be as close to negative 9.8 as possible.
Okay. So shooting. Horatio Luke Bottom is a gangster. and he was shot at the local gangster meeting. And, you know, in a room full of gangsters, there were a lot of guns in the audience. And so there are 3 main suspects. So they had 3 different types of guns. Each had a different muzzle velocity. Your job is to take the evidence from the police examiner. You have information about entrance and exit wound, where the bullet was. Now, when a bullet goes through a body, it slows down. And they gave you a number. It's going to slow down about 30%. And based on where the bullet landed, I want you to tell me who done it. Who shot Horatio? Okay? Are y'all up for it?
Oh, yeah.
Yeah.
Okay. So this is taking real ballistics evidence and figuring out how. So go ahead and take one and pass it. Figuring out how to take what you know and apply it to a real life situation. So again, put your work on the board. Show evidence for your claim. It's more complicated than the ones you've done. But if you keep track of your measurements, it's not really that
What is the bullet lead in there? So here to here it went down 0.05.
He was standing here and the bullet hit the wall. So did the bullet hit at the same height? Oh, okay. So you know how far down the bullet dropped?
This is where it went.
Okay, that's where it went in.
And then we do this.
So what does the difference between that height and that height mean?
That was all.
The bullet.
How far the distance was.
Yeah, that would be
You didn't shoot him at an
That's 3
angle.
meters.
So,
I think that's what it says in here.
The shooter's 5.6.
Sketch the path of the bullet. What would the path of the bullet look like?
No, there's initial on final velocity.
So this is where it exited his body.
Yeah.
Okay, what else do you know?
This is for
You know how far horizontally the bullet traveled after leaving his body. What else do you know from that sheet of paper?
it goes down 0.55.
Okay,
So
put that down. That should be delta y. What else do you know?
the initial velocity was 0.
We just figured out the velocity.
Well, this is in millimeters, so let's get it to meters so your units will cancel.
Yeah, we're doing this.
Because it slows down to. I did all about this. Add that 30% back.
Okay, you did that already, so you're ready to compare. So can you find how fast was the bullet going?
What was your time?
That's for the first question.
0.03 seconds.
Show your work on your board so when people have a question.
0.34.
Hurry up. Y'all remember? Okay. Okay, since we're done, would y'all mind going around and asking other groups? And if they want a hint, you could give them a hint, but please don't tell them the answer. But if they're stuck on which way to go, okay. Sketched out? Okay.
We found like how much, 30% of that work.
Yeah,
Add
I'm
this
doing
back
on
to
the
it.
flow down.
Yeah, this is
Okay. So you found, this is the acceleration, this is delta y, you found the
So we
time.
have all this time.
And so, in that 3 meters, if it took that long, this was the speed. And so this is 30%.
That's, okay, yeah, that makes sense.
Well, this is 70% of it, right? Because it slowed down 30%, as it passes through. Okay, I don't know, check your work.
The .30 find the like as a loss.
Final velocity.
Oh, you got that?
Justin? Okay, I know you like this kind of thing. So you wanna go into something in this field, the FBI? Okay, you're up. Who else? Okay. Tell me how you approach this problem. And what were the keys to solving this problem?
45 ACP just wouldn't have enough power to move, so we narrowed it down.
Took all the velocities of the muzzle, and since they were slowed down to 30% after they were exited, it was like 132 for the .338. No, it was the Magnum.
For the Magnum,
Yeah.
For the Magnum was 132, then the .38 special was 90, and then the .45 was 75. And so we found everything we knew, which we knew that the horizontal velocity, the acceleration was 0, and for y it was negative 9.8 due to gravity. The distance between him and the wall was 3 meters, and the distance of how far it fell from the exit wound to the wall was 0.0055 meters, or 5.5 millimeters.
Okay, so they gave you 5.5 millimeters, and you had to convert that. So
At this point, we plugged in the velocity of the gun barrel. We did the
387.
387, and I did the special .38, yeah. Which putting 90 here and 0 here, since the initial velocity coming out of the exit wound is 0. Use the second formula for both of these. For the first one, it cancels out since A is 0, so it's basically delta y equals initial velocity times time, which gets you 0.3 seconds. Going over here to the same. Whoops. That cancels out to 0, so it's 1/2 of the acceleration times
Okay.
time squared.
I'm going to stop you. Out here, do y'all have any questions for Adam? Okay. Yes.
Delta Y says .0055, and under,
Negative 0.0.
yeah, and below it says .055. I don't know if y'all,
Oh, whoops.
I don't know if y'all just wrote it wrong. That's all.
Alright, well, doing this, it's right in my calculator, 0.0055 divided by 4.9 was 0.001122, and take the square root of that, both sides, so you have t equals the square root of all that, and gives you 0.03 seconds, which matches.
I like their strategy. Did you kind of follow that? They kind of back solved. They found each of those velocities, and they figured out what would it be when it slowed down, and they kind of back solved for each gun to figure out which one matched. Jack and Caitlin, did y'all do it a little bit differently?
We didn't solve for any of the guns, the velocity after. Instead, we just tried to find the velocity as it left, and then did a little ratio with the percents, 30 over 100 and 90 over x, and we got 303, which was the whatever gun it was that Jackson used.
Okay. But in either case, both of you came to the same conclusion that Janice Jackson had the gun that was fired. Okay. And Horatio lived to tell the tale, and Janice went to jail, and you guys did a great job of being the detective. Okay, and this was tougher, wasn't it? This was much tougher than the problems that we've been doing. You had, like in real life, you're not given A, B, and C. You have a lot of information, and you have to pick and choose what's relevant to the problem. Okay, and I think y'all did an excellent job. Thank you, guys. So go ahead and have a seat. Keep your boards. Have a seat. After today, what could you do with what you know about projectile problems? Okay, you could solve murders. You could. Okay, you could figure out if videos are real. You could analyze them, and taking what you know about projectiles, you could see if something really matched the model that we've been working with. What else could you do?
Find out where something went.
Okay, you could find out where something went.
Be a physics teacher.
You could be a physics teacher, absolutely.
Fire cats out of cannon.
You could fire cats out of cannons,
You thought Kobe a fake.
or maybe not. Y'all didn't really come to a clear, conclusive answer. This class was divided half and half. So I think you would need to do it again. So good science. So let's go back to that Kobe video. Good science. You do a lot of trials, right? How many trials usually?
About 3 times.
A minimum of 3. How many trials did you do today? You did 1. So do you think, now, the whole class did it, and you were about half and half. So I think we could kind of say that's more trials, but if each group did it multiple times, I think we could probably come on to a more conclusive answer. But your answers were pretty close. You can also you can have a copy on your computer at home, which I suggest you do it before you go off to college, because it's a nice tool that makes it easy for you and it's free. Take it and play with it some more. I think it's not conclusive, but I don't think we can reel out that it's fake based on the evidence today. But we also can't say for sure that it's real. So if you're interested, go home, grab that off of my website, do some more investigation. If you get evidence, bring it up to the class. We'll go over it again. We'll look at that again. So, any questions? Okay, your homework tonight, projectile number 2, problems 1 through 4. Go ahead and wipe your boards. Put them where they go. And y'all have a great day.